Hey you guys, I just wanted to go over some of the questions on the pretest for your introduction to geometry and transformations. So I'm going to do the first half, okay? Before you get started, I highly recommend, if you haven't printed out or written down the cheat sheet that I sent you, it's been several posts ago, I would have this in front of me definitely when I took the post test. It would be extremely helpful. But anyway. All right, for the first one, it says, with regards to mathematics, what is an accepted statement of fact that is used to prove other statements? Well, a theorem is something that has been proven to be true, so that's not going to be the right answer. The right answer is an axiom. It's something that's accepted as true that hasn't been proven true. I think you all know what a definition is. And an undefined term, there are three undefined terms in geometry, and that's point, line, and plane. The next one says, which Greek mathematician is known as the father of geometry? The father of geometry is, of course, Euclid. You know, he wrote that book, Euclid's Elements, and it was all about geometry. Number 3 says, which statement is not one of the axioms of Euclidean geometry? And y'all, please be careful for questions like this where they don't want what is, but what is not. Just be careful. The answer to this one is D, and it says, if two planes intersect, their intersection is a point. I'm going to try to sketch this for you. But if you think about what this would be like, if you have two planes intersecting, oh goodness. Well, that's as good as Miss Latham can do. When two planes intersect, they intersect at a line, not a point. The other three are good. Okay? For the next one, and you guys, this is just facts, right? We don't have to apply math for this. It says match mathematician to their descriptions. So we just talked about this. Euclid is regarded as the father of geometry. I'm going to be lazy and just draw a line like this. Hippocrates, and I may be saying that wrong, he got some geometric facts together and he wrote a textbook. So this is him right here. He was a mathematician, obviously. Now, everybody knows Pythagoras. He has a theorem named after him, and it is the Pythagorean theorem, which is, of course, a squared plus b squared equals c squared. And then Thales was a philosopher, and he has 5 theorems that have been contributed to his name. For number 5, it says, use numerals instead of words. All right, AB is parallel to CD. So I'm going to sketch this, okay? So we got AB, and it is parallel to CD. Anytime you have a problem and they don't give you an illustration, I highly recommend making your own. And remember, when lines are parallel, they mark it like this with these little things. It says EF is perpendicular to AB. Perpendicular means they intersect to form right angles. Well, if it is perpendicular to AB and CD is parallel to AB, then guess what? This line is going to keep on going over here and also be perpendicular to CD. So the number 90 degrees. So how many 90-degree angles do we have? So if this is 90 degrees, so are all these, right? Because, you know, they're perpendicular. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Okay? All right, for number 6, it says AB and PQ are parallel lines. So I'm going to go ahead and mark that like this. It says CR and DS intersect the two lines as shown as the figure, and I immediately noticed that they're perpendicular. It says, which statement is true about CR and DS? All right, well, you guys, if these lines are parallel and these two are both perpendicular, so CR and DS are both perpendicular to AB. So that means that these lines have to also be parallel. And since these are parallel and they're perpendicular to this one, that means they're also going to be perpendicular to PQ. If you look at what you got here, it's a parallelogram with 4 right angles. So basically this is a rectangle. This right here. Rectangle. And we know when we have a rectangle, or any parallelogram actually, the opposite sides are congruent. So those two are equal in length. These two are also equal in length. So that would mean that CR is equal to DS. They're the same length. All right. Let's look at this one. It says, by which angle must AB turn about point A in a clockwise direction so that it coincides with AE? So here's AB. And remember, clockwise would be this way, right? And we want it to come over here to AE. So how many degrees would that be from here to here? Well, it's half a circle, which is 180 degrees. Okay. It says Jonathan is standing at a fountain. This is the center, so we have a circle. This is the center of the circle. And then we got a pizza shop, a gift shop, and a bookstore. If you'll notice, the gift shop and the bookstore are on the actual circle. And it wants to know which statement must be true. Well, here's the thing. We know that all radii of a circle are congruent, right? This is just the length of the radius, and this is the length of the radius. So the distance from F to G has got to be equal to the distance from F to B, because they're just whatever the radius is. The only other thing we could say we definitely know is that the distance from F to P is greater than F to G or F to B, and that's not an option here, okay? All right, it says select the correct answer. The figure shows 3 parallelograms, so this is the pre-image. And first they want to know how we get from here to here, what transformation took place. And we can see that that is a reflection across the x-axis. So reflected across the x-axis. There we go. All right, and then they want to know how we get from here to here. And even though it's on the other side of the y-axis, I can see that that's not a reflection. It's going to have been rotated, right? So if we went counterclockwise, if we went clockwise, that would be 270 degrees. But if we went counterclockwise, that would be a 90-degree rotation. So I'll have to see which one we have. There we go. Rotated 270 degrees clockwise. They have 90 degrees clockwise, but 90 degrees counterclockwise is not an option. Of course, 90 degrees counterclockwise and 270 degrees clockwise are actually the same thing. You'll end up in the same location. Just, you know, this is clockwise, this is counterclockwise. Just making sure. Let's look at number 10. It says they transform this to this, which transformation, here we go again, did not take place. They throw that word not in there, so just be careful. Let's see, a rotation 180 degrees clockwise. So if I rotated this 180 degrees, would I end up here? Yes, you would. A reflection across the origin is actually the exact same thing. You end up in the exact same place as 180 degree rotation, so that works too. A rotation 180 degrees clockwise. Well, 180 degrees counterclockwise and 180 degrees clockwise, you know, here to here or here to here, that'll get you in the same situation. So all of these three things mean the same thing. A reflection across the line y equals negative x. All right, well, y equals negative x is like this. And you can see if you reflected this across this line, the triangle would be up here, not down here. So this is not what happened. It says the figure above the x-axis is the preimage. The figure below the x-axis is the image. Which transformation produced the image? All right, a reflection across the x-axis. No, that wouldn't. You would have your little, this hump here would be here, if you can imagine that. So that would not work. Now, a reflection about the origin, remember, that would be no different than a 180-degree rotation. And do you see how that looks exactly the same this way as it does this way? So that's going to be the correct answer. And of course, 90 degrees clockwise, this would just move 90 degrees this way. So this would be over here. That doesn't work. A 90-degree counterclockwise rotation would take this hump down here, so that also would not work. All right, it says we have this polygon, here are its points, match the coordinates to the transformation. All right, so -2, 2, that would be a rotation 90 degrees counterclockwise. Where is that at? That would be if D 90 degrees counterclockwise. All right, remember, if you do a 90 degrees counterclockwise rotation and you have a point like this, it's going to be changed to negative yx. And if you look at D, D is at 2, 2. So if you switched them, well, obviously they're both 2, so switching them is not that big of a deal. But you got to negate the, what was the y-coordinate, so that would become -2, 2. All right, let's see here. For -2, that would be a 180-degree rotation. Where's that at? Okay, that's right here. All right, and it's talking about A. So remember, if you do a 180-degree rotation, and I'm not specifying clockwise or counterclockwise, because remember I showed you those mean the same thing. What that does to your point is if you have a point xy, that'll change it to -x, -y. So if you look at A is located at -4, 2. So if you negate, that will become 4, -2. All right, let's just do 4, 2, I guess. 4, 2 would be a 270-degree counterclockwise or 90 degrees clockwise, but I can see that for point B, that's not an option on here. If you think about a 270-degree counterclockwise rotation, what that's going to do to your point, remember, again, it's going to flip, but this time it'll negate the x. So it was located at -2, 4, and when we make those transformations, it would become 4 because y comes up front, and then what was a -2 will become a +2. And then the last one, the 3, -1, is a 90-degree rotation clockwise. Can y'all see? All right, so if you do a 90-degree clockwise rotation, what that does to your point is it'll become y -x. Because remember, 270 degrees counterclockwise, if I go 270 degrees this way, it's the same thing as going 90 degrees this way. And so for C, it was located at 1, 3. So if you make that transformation, it will become 3, -1. Thank you for watching.